So now let's do another example for one mean hypothesis z-test with sample statistics. Suppose that a recent article stated that the mean time spent in jail by first-time convicted burglars is 4.1 years. A study was then done to see if the mean time had remained the same in the new century. A random sample of 107 first-time convicted burglars in a recent year was picked. The mean length of time in jail for the survey was 4 years with a standard deviation of 0.6. Suppose that it is somehow known that the population standard deviation is 0.57. Conduct a hypothesis test where the level of confidence is 95% to determine if the mean length of time has remained the same. Assume the distribution of jail time is approximately normal. All right, let's go back and see what I have. So the first thing I'm going to look at is I have a sample of 107 burglars. Okay, I have a sample. So what does that mean? That would be, I'm going to look down here. That's my sample size. So I have 107 burglars. Okay. And then it wants to know, let's do this. I'm going to keep going with that. So I had a sample and it said that the mean length of time from that survey was 4 years. Okay. So again, I'm going to highlight this so I know where everything's coming from. So that means my sample mean is 4 years. And then it says with a standard deviation of 0.6 years. All right, so then I have my standard deviation, my sample standard deviation. So I can do 0.6, 6 years. Okay. So suppose it is somehow known that the population standard deviation is 0.57. All right, so then I have my population standard deviation. So I'm going to just mark that right there. So the one thing that I am missing then is it says the mean time spent in jail is 4.1 years. Okay, I've dissected what my sample was. So again, my sample mean was 4 years. My sample size was 107, and my sample standard deviation was 0.6. So that means this last one that it stated that the mean time spent in jail was 4.1 years. So that is my population mean. Okay. And then the other thing that I need is it gives me a confidence level of 95%. So I can add that. But this problem doesn't ask for the level of confidence, it asks for the level of significance. So remember, I convert level of confidence to a decimal. 1 minus 0.95 equals, 0.05. Okay. So I've dissected this problem. I suggest if you have highlighters or if there's a way you can write it down, using the flowcharts will help a lot with these problems to dissect them. I need to go back and answer A. Why is this problem a one mean z-test? And it's because I have a population standard deviation. Okay, and that's the only reason I'm doing that is because I have a population standard deviation. So I have answered everything else. Now the next step is null and alternative. So what did they want to know? They wanted to know if the mean length in jail time had remained the same. That's another way to say equals. So remember, the equal sign has to be in the null. And if I turn the word null to a vertical position, I can see that those two L's make an equal sign. That's how I remember it. So then I'm going to do this. I'm going to insert my mean sign, go into symbols, mean. Okay. And this wanted to know that it remained the same. What remained the same? The population mean. Okay. So if the null is equals, that means the alternative has to be not equal. So let me go find that sign. Hopefully it's in here. That's easy to find. Yeah, there it is. There's my not equal sign. Okay, I insert it. And then again, 4.1 years. All right. The only difference between the null and the alternative is the sign that's in the middle of the mean and the actual values. That's it. So now I'm going to get my z and my p-value. Well, I need to go add that to Minitab. So I'm going to open up Minitab. And again, I'm going to go to Stat, Basic Statistics, one sample z. I've got summarized data. Okay, so my sample size was 107. My sample mean was 4. My population standard deviation was 0.57. My hypothesized mean was 4.1. And again, I'm getting all that information from here. I maybe gave you more information than you needed, but I'm trying to break it down so you see how I broke down everything, because I know a lot of people don't like word problems, and this is a way for me to help you get through these word problems. Okay. Going back to Minitab, my options. All right, so remember I said what was my level of significance? It was 0.95, or level of confidence, so it's fine. I can keep it that way. The alternative is going to be the not equal. This alternative here must equal whatever your alternative sign is right there. And then I hit OK, and then I hit OK. And then I'm going to take this and I'm going to copy it and bring it back over so I can see what I'm doing. All right, so I'm just going to paste it here. And again, it helps me to compare my alternative hypothesis with my alternative hypothesis to make sure I'm doing it right. So my Z value is negative 1.81, and my P value is 0.070. Okay, now I got to compare my P value to my level of significance. So 0.070 compared to 0.05. If you're having a hard time with this, just add that extra 0 so that the decimals are the same. So I definitely know that 70 is greater than 5. So I'm going to put this in there, and that means I need to fail to reject the null. Okay? All right, so let's go back up here. So they wanted to know if it had stayed the same, so that was my original claim. And I always mark mine just so I can so it's easier for me to go back and do. And because I failed to reject the null, that it was true. And that means my alternative is false. So my original claim is true. So yeah, we did find it. So what I'm going to do is, I'm kind of being lazy here. I'm going to go copy this here, and I'm going to show you how I make the conclusion based on that. So I'm going to put this here, and I'm going to say at the level of confidence of 95%, I'm going to get rid of the extra words, comma, the mean length of jail time has remained the same. And if I wanted to, again, I could do what my Z value is and what my P value is, but I'm just going to stop at this. So yeah, what did we find? I'm going to get rid of the highlighting so it might be easier to look at. At the level of confidence of 95%, the mean length of jail time has remained the same. So it hasn't changed. So even though they looked at this sample to see if it had changed, it hadn't. And that's why we do hypothesis testing. So again, I'm looking at some kind of population that I believe is what it's always been, that I'm thinking my population is always consistent with this. And then I get a sample to compare it just to make sure that it's the same. That's why we do hypothesis testing. I hope this helped.